Hey guys, it's Mr. Mulvihill here. Hope you guys had a good weekend. Nice 4-day weekend, so that's nice. Unfortunately, I can't be here today. I'm here with you guys across the virtual world. So what we're gonna do today is kind of stuff we've done in the past. We're gonna do some notes. You guys are gonna follow along as we work, and then you guys will have some opportunity to practice. So before we get into the new part, I do want to just hit that bell here quick, and the important part is taking each piece of a mystery word problem and putting it into math with the phrase my number becoming x or integer or my number is x. We're going to use that today, and it's really just going to be the same thing. We're going to go one more step up the ladder, one more difficulty, just like solving equations, where we took it one more step. We're going to do that today. But it's all built on that same foundation. Okay, so if we're looking at our notes today, what do we got? We got consecutive integer games. So let's actually start with this. If you can flip over your paper, flip it over, and here's your riddle. Let me think. Okay, I'm thinking of two numbers, two now, and the numbers are back to back. They're back to back. So what does that mean? Like, for example, 5 and 6 are back to back. 100 and 101 are back to back. So I'm thinking of two numbers that are back to back, and when you add them up, you get 41. I'm going to give you guys 30 seconds, flip over your paper. Don't shout out. Don't shout out. Write on your paper what you think that is. I'll give you guys 30 seconds. We can pause the video and see what you guys got. So I'll say it one more time. I'm thinking of two numbers that are back to back, that when you add them up, you get 41. So we can pause the video. All right, so you should have gotten 20 and 21 because 20 plus 21 gives you 41. So if you got that, you pretty much got it. Now they're going to get more difficult today. We're going to use different words than back to back, but that is what we are going to do today. We're going to create equations and solve them from there. So we use the word numbers and back to back. You guys can remember from, early on, 7th grade, the word integer was used. You have integers right here in your notes, and those are just whole numbers, positive and negative. You guys got that definition right there. You might want to write into your own words. This is the formal definition, the actual technical mathematical definition, but if you want just kind of in your own words, feel free to do so. I might put basically every whole number, including negatives and even 0. So you can put that there for yourself or in your own words, which if you do it that way, you'll remember it better. All right, so if integers are basically every whole number, including negatives and 0, what are consecutive integers? Well, consecutive, you may have heard that word before. It really just means back to back. So the Golden State Warriors, they won a championship in consecutive years. They won it back to back in whatever it was, 2015, 2016. Consecutive means one after the other. So you might have like 4, 5, 6. Those are consecutive integers. They go one after the other. You might also, you could have negative consecutive integers like negative 12. Whoa, we're going to slide that over here. Negative 12, negative 11, negative 10. You guys can create your own just over here if you want. Get another few consecutive integers. Do leave room though, because we come to the most important part algebraically today. Consecutive integers 4, 5, 6, negative 12, negative 11, negative 10. Those are all in a row on your number line. But we sometimes don't know what the number is, like what you just did. Back-to-back numbers that add up to 41. We didn't know what those were, right? Like that's what we were trying to find. So if you don't know what a number is in math, what can we call it? We call it x. My number is x. So if you have x, here's the challenge. 1 of 3. If you have x and you're doing consecutive integers, back-to-back integers, what would the next number be? The first number is x. The next number that follows x would be what? In other words, 4, the next number after 4 was 5. But if the first number is x and it's not 4, how could you represent the next number? Think about that. How could you represent the next number? You're going to represent it by x plus 1. X, add 1 to it, and that's going to give you consecutive integers. And then the next one after x plus 1 will be x plus 2. And these would be 3 consecutive integers no matter which ones you chose. All right? Consecutive even, consecutive odd, we're going to hold off on that, and you might think what that might mean. Actually, real quick, why not? What would consecutive evens be? Well, even numbers are, 2, 4, 6, 8, all those numbers that are divisible by 2. So if we did consecutive evens, and our first number was 12, what would our next consecutive even integers be? 14 and 16. Same thing for odds. Say we had an odd number of 23. The next odd number would be 25, followed by 27. These are consecutive evens. We are skipping a spot, but we're not skipping an even number. We're going to the next even number, the back-to-back. All right. So we're going to take this knowledge and we are going to do some of these equations. Let's all look together at exercise 1. So it says, let's work with just 2 consecutive integers first. Say we have 2 consecutive integers, back to back, whose sum is 10 more than the first number. So you have 2 back-to-back integers whose sum, when you add them together, it's 10 more than that first number of the 2. We're going to pause this video. I want you guys to just play around with it in this space. Maybe you set up an equation, maybe you don't. See if you can come up with it. All right, so maybe you came up with the correct numbers. You can test it out too, so you would know if you're right. If that was a little tricky, what we can do is solve it the algebraic way. Remember how like a week ago I gave you all those challenges and you actually rose to the challenge a lot of the time. But it became easier when we could just write an equation. That's what we're going to do here. We're going to write an equation. So here we go. Now, carefully set up let statements. I'm reading here. Carefully set up let statements that give expressions for our 2 consecutive integers. Using these expressions, set up an equation that allows you to find them and solve the equation. So, if we're dealing with 2 consecutive integers here, you guys can underline that. 2 consecutive integers, we don't know what they are, right? So we're going to say the first number, aka integer. The first number, we don't know what it is, right? It's x. So if the first number is x and they're consecutive, if we scroll back up, if we look up here, the next one would be this guy, x plus 1, our second number. So if our first number is x, our second number, is x plus 1. And now what we're going to do is we're just going to take what is said in this question. We're going to put it into algebra. So let's see. Say we have two consecutive integers whose sum, okay, so sum means we're going to add the two numbers together, right? So we're going to do x difficult, x plus the second number, which is this one. So we're going to do x plus 1. And then, so what about the sum? It says whose sum is 10 more than the first number. So is means equals, so whose sum is 10 more than 10. What does more than mean? Plus. Okay, so 10 plus, well, plus what? The first number. Oh, what's the first number? Oh, the first number is just x. So there you go. There's your equation. We're going to pause the video, solve it. And after you're done solving that, try question 2. And then we'll go over it. All right, so you guys just tried 1 and 2. Hope you guys got the right answers there. I'm going to try number 3. It's a little bit different, a little more tricky, but nothing crazy. So we're going to set up our let statements. Well, first we're going to read the question. I'm thinking of two consecutive integers. Okay, back-to-back numbers. 10 more than twice the first number is 7 less than 3 times the second number. What are the two consecutive integers? All right, so to make this easier, we're going to write our let statements. It just makes it easier. So let the first number be x, and since they're consecutive integers, we're going to let the second number, if the first one's x, the next one's x plus 1. And now we're just going to take this piece by piece and write an equation. So 10 more than, okay, we're just here, 10 more than, that becomes 10 plus. Well, 10 plus what? Twice the first number. Okay. Twice, so 2 times the first number is x, so 2x is equals, that's where that is. Okay, 7 less than, okay, so we know that less than, we're going to switch up the order, so whatever it is, it's going to be minus 7. Well, what are we minus 7 from? 3 times the second number, so 3 times the second number. Well, what's the second number? X plus 1. Now, oh, wait. If we just did 3x plus 1, that's saying 3 times x. 3 times the first number, but it's 3 times the whole second number. So you might have guessed it. We're going to have to put parentheses around this. And look, there's just another equation to solve. Go ahead and solve it. We'll pause the video, we'll get an answer to you, and we'll come back. And after you solve number 3, I want you to work on number 4. And then we'll stop at 5, and that will be the last one I'll do with you. All right, coming back to you. I hope you got 1, 2, 3, and 4 all right. Here's the last one, number 5. I'm thinking of 3 consecutive integers. Well, if the first number is going to be x, the second number is going to be x plus 1. And since we're dealing with 3 consecutive integers, the third number, we can represent that. We don't know what it is, but it's got to be x plus 2. 2 more than the first one. All right, and then we're just going to take it piece by piece. Let's see. When I add them all up, oh, this is easy. We're just going to add them all up. So x plus 1 plus the third number, which is x plus 2. Okay, so we're going to do plus x plus 2. And what about the sum? I get 51, so I get would mean equals. And bada bing, bada boom, you got yourself an equation. Go ahead and solve it, and you're going to complete the rest of these questions for the rest of the day.